Okay, this is part of the homework for the section 6.1. Let's solve 11, 13, 15, 17, 19, and 21 example. Okay, let's open one piece of paper in blank. Okay, let's do number 11. I need to evaluate this, and this expression, and the function is f of x equal to x, and g of x is equal to 3x squared plus 1. Okay, let's do the first one. The first one is, you evaluate first g and 4. G and 4 is 3, 4 squared plus 1. 4 squared is 16, is 3 times 16 plus 1. 3 times 16 is 48 plus 1 is 49. And now you evaluate f, evaluate 49. F is, this is 2 times 49 is 98. And this is the answer. Now you evaluate now the second expression is f, evaluate 2. Is 2 times 2 is 4. Now evaluate g, que is the second, at 4. Is 3 times 4 squared plus 1. I did before. Is 4 squared is 16 times 3 is 48 plus 1, 49. Okay, this is the first, this is the second, and the third one. F, evaluate 1 is 2 times 1 is 2. And f again, evaluate 2 is 2 times 2 is 4. And the answer is 4. Okay. This is the number 1 is this. Number 2 is this. Number 3 is this. And number 4 is g evaluate 0 is 3, 0 squared plus 1. It's obvious because 0 squared is 0 times 0 is 0 is 1. And g evaluate at 1 again is 3, 1 squared plus 1. 1 squared is 1 times 3 is 3, and 3 plus 1 is 4. As this is the answer for number 4. Number 4 is a coincidence, is 4. Is 4. Okay, super. Okay, 13. Let's do the first one. The first one is g. G evaluate at 4. And the expression of g is 2 times 4. Is 8. And this 8 evaluate the second function, que es f. Entonces f evaluate at a. This is square root 8. Square root 8 is equal to radical 2. Because a is 2, 4. And square root 4 is 2. And this is the first answer. Second, but this is for 1. For 2, evaluate f, evaluate 2. Is radical 2. And after that, g evaluate radical 2. Is 2 radical 2. It's the same. It's a coincidence, not always it's the same. Number 3 is f evaluate 1. F evaluate 1, and f is radical 1. The radical 1 is 1. And again you evaluate 1. Is radical 1 is 1. The answer is just 1. And g evaluate 0. 2 times 0 is 0. Again, g evaluate 0 is 2 times 0 is 0, and the answer is 0. Option 4. Okay, this is 17. Let's do it in the first. Evaluate g of 4. It's 1 over 4 squared plus 1. It's 1 over, this is 4 squared is 16 plus 1, 17. 1 over 17. Okay, now you evaluate in the function f. F evaluate at 1 over 17 is actual value 1 over 17, is 1 over 17. This is the answer for the number 1. Number 2 is f evaluate 2. The actual value 2 is equal to, and g second. G evaluate 2 is 1 over 2 to the second power plus 1. 2 to the second power is 4 plus 1 is 5, 1 over 5. Number 2. And number 3 is f evaluate 1. Absolute value 1 is 1. And again, f evaluate 1. Absolute value 1 is 1. The answer is 1. For the question 3. And g evaluate at 0 is 1 over 0 squared plus 1 is 1 over 1 is just 1, and after you evaluate g and 1 is equal 1 over 1 squared plus 1 is 1 over 1 squared is 1 plus 1 is 1 half. Equation 4. Equation 4. Okay, 19. This is f of x, this is a g of x. Let's solve the first part. G evaluate 4 is cubic root of 4. This have no simplification, more simplification. Now, f evaluate a cubic of 4 is 3 over cubic root of 4 plus 1. And you leave it at that. This is the answer for the number 1. Number 2, f evaluate 2. F evaluate 2 is 3 over 2 plus 1. It's 3 over 3 is 1. And g evaluate 1. G evaluate 1 is cubic root of 1 is 1. The answer is 1. F evaluate 1 is 3 over 1 plus 1 is 3 over 2. And f again evaluate at 3 half. The expression is 3 over 3 half plus 1. 3 half plus 1 is, for example, you find the LCD, gets 2, is 3 plus 2, and 3 here. This is 3 over 5 over 2. Now, flip it. Okay, this is 3 over, here, much better, we have a space here. Is 3 over 1 times 2 over 5. Is 6 over 5. That's the option 3. Now the last is g. G evaluate 0. It's like a cubic root of 0 and 0. And again, g evaluate 0 is obviously 0. The answer is 0, corresponding with the option 4. Okay, 21. 21 is different. 21 is determine or find the domain of the composite function. And the domain for the composite function is equal to the domain of the first, so the domain of g. intersection domain of new expression. Okay, the domain of G is equal all real numbers such that x is most different to 0. Okay, that's a new expression. Is F composition G is like a 3 box minus 1 2 over x. Okay, G inside F, this is like a 3 over the common denominator is x, 2 minus x. Now flip it, this is 3 over 1 times x over 2 minus x. That's the domain of the new expression is obvious, is all real number except 2. I'm looking here in the denominator. Now, final answer, domain of F composite G is the union, this and this together. This is x such that x must be different to 0 and x must be different to 2. Final answer. Okay, let's continue in this video 23, 25 and 27 in the same section. Okay, let's continue 23. Domain of the first function is G is all real number except 0. You see here, right? And new expression is F composition G is G inside F is box over box minus 1. Inside the box we have 4 over x. 4 over x is 4 over x over 4 over x minus 1. LCD is x is 4 minus x and 4 over x. Okay, now you copy the first, you flip it the second, cancels out the x, the answer is 4 minus x. Perfect. So domain of the new expression is equal all real number such that x must be different to 4. Look at this denominator. And domain of the composition F composition G is equal x such that x must be different to 0 and must be different to 4. Done? Okay, 25. Again, same procedure. Domain of the first function is G. We have no restriction, it's linear function, it's all real number. Okay, new expression. New expression is F composition G is G inside F. This is radical 2x plus 3. In this case we have restriction. The restriction is 2x plus 3 must be non-negative. So 2x greater than or equal minus 3 divided by 2 is minus here. X is greater than or equal minus 3 over 2. That's the domain for the new expression. Then the domain of the composition is the combination of this and all real number, okay, obviously is this. X such that x is greater than or equal minus 3/2. This is 27. It's the same idea. Find the domain of the composition in this order. F composition G. The domain, first domain of G. The domain of G is, as a radical, you take the expression inside the radical, must be non-negative. X must be greater than or equal 1. So the domain of G is equal X such that X must be greater than or equal 1. And now new expression. New expression is F composition G is G inside F. It's like a box square plus 1, and inside we have square root x minus 1. Cancel out square root and square. We have x minus 1 plus 1 is x. Then domain of the new expression is all real number. Now domain of F composition G is the composition, the intersection this is this, then is x such that x must be greater than or equal to 1. That is the answer.